Hello students, this is fourth video of topic solution. From this video we are going to learn vapor pressure of solutions of liquid in liquid and Raoults law. Let's study vapor pressure. All liquids exhibit tendency for evaporation. The tendency of evaporation of the surface molecule is due to those molecules which present on the surface of liquid, they absorb energy, and at a particular state the high energy molecule escape the surface and they convert into gaseous state. If the intermolecular forces of attraction are weak, that energy level they readily get and they convert into gaseous state and they lose liquid state. So they exert that gaseous molecule which comes from that liquid surface, they exert a vapor pressure, a pressure on the surface of liquid. Let's see evaporation and condensation. In that container a liquid is taken. I already mentioned the surface, the molecule present on the surface, they absorb energy. After absorbing energy of a specific amount, they escape that liquid state and goes into gaseous state. That is tendency of evaporation. As the intermolecular force of attraction are weak, the liquids evaporate easily. As you know, the process in which liquids are converted into gases, that is called evaporation, and as the rate of evaporation is depend upon temperature, but one factor, that is intermolecular forces of attraction between the liquids, that decide the evaporation process. If the intermolecular force of attraction are weak, the liquids evaporate easily. Such liquids are called volatile liquids. Now, as the container, both our container are sealed with lid, liquid escape from an open vessel by evaporation. If now here the vessel is closed, the process of evaporation continue. The process of evaporation continue, but that gaseous molecule, those are evaporated from liquid state, are collide on the wall of the container. So these molecules of vapor are in random motion, so they collide with each other, the wall of the container, and as a result of the collision they loses energy, and that loses energy that much they again converted into liquid state, the process called condensation. First evaporation, that is conversion of liquid state into gaseous state, whereas second one, the condensation, that is conversion of gaseous state into liquid state. Initially, as this process carried out at same temperature, the rate of evaporation is occur at constant rate with proper rate, but initially the rate of condensation is minimum because of lesser number of gaseous molecule are present in the given volume. But as the gaseous molecule increases, the rate of condensation also increases, and at a particular stage the rate of evaporation is equal to rate of condensation, that is equilibrium. That is equilibrium is established between two phases of a substance, where that is equilibrium between liquid and vapor. So the pressure exerted by that gaseous molecule on liquid surface, that is vapor pressure. So vapor pressure of a solution of liquid in liquid, it is defined as, let's see, vapor pressure is defined as the pressure exerted by gaseous state of the substance whenever it is equilibrium with liquid phase. That is, I already mentioned, a dynamic equilibrium is established between liquid and gas. That time, the pressure exerted by the gaseous state on the liquid surface, that is called vapor pressure. Let's see volatile liquid. The liquids in which intermolecular forces of attraction are weak and evaporate easily called volatile liquid. मगाशी सांगितल्याप्रमाणे लिक्विड दोन प्रकारचे असणार आहेत and this classification based on intermolecular forces of attraction between the molecules of liquid. ज्या लिक्विड मध्ये इंटरमॉलिक्युलर फोर्सेस हे वीक असतात ते इझिली इव्हॅपोरेट होतात, दॅट इज कॉल्ड व्होलाटाईल लिक्विड. आणि दुसऱ्या प्रकारामध्ये इंटरमॉलिक्युलर फोर्सेस ऑफ अट्रॅक्शन स्ट्रॉंग असल्यामुळं दे लेस इव्हॅपोरेट इझिली, त्यांचं इव्हॅपोरेशन हे तितकं इझिली होणार नाहीये. अशा लिक्विडला नॉन व्होलाटाईल लिक्विड असं म्हटलं जातं. आपण फोकस करूया फक्त व्होलाटाईल लिक्विडमध्ये. तर लिक्विड अशा लिक्विडमध्ये ज्यांचे इंटरमॉलिक्युलर फोर्सेस वीक असल्यामुळे ते इझिली लिक्विड स्टेट यूज करून गॅसियस स्टेटमध्ये जाणार आहेत, त्यांना व्होलाटाईल लिक्विड्स असं म्हटलं जातं. लेट्स सी सम एक्झाम्पल ऑफ व्होलाटाईल लिक्विड. इथाइल एसिटेट, एसिटोन, इथाइल अल्कोहोल, these are the examples of volatile liquid. This molecule, the intermolecular forces are weak, so they easily evaporate and leaves the liquid state and convert into gaseous state. Let's see, in that container two components are taken, A1 and A2. Here both the components are volatile. That is, both the liquid has tendency for evaporation easily because of the weakened intermolecular force of attraction between them, and they evaporate easily and exhibit vapor pressure on the liquid surface. This is binary solution of two volatile liquid A1 and A2. The partial vapor pressure of component are related to their mole fraction. So, I already explained vapor pressure. Now here, two components A1 and A2. The red dot for that of A1 and that green dot for that of A2. So both the molecules of that volatile liquid exert vapor pressure on the liquid surface. And this partial vapor pressure of component are related to mole fractions of A1 and that of A2. P1 and P2 are partial vapor pressure of A1 and A2. A1 चं partial pressure असणार आहे P1 आणि A2 चं partial pressure असणार आहे P2. Whereas P1 naught and P2 naught are vapor pressure of pure component A1 and A2 respectively. प्युअर कॉम्पोनंट A1 असताना त्याचं वेपर प्रेशर असणार आहे P1 नॉट आणि A2 प्युअर फॉर्म मध्ये असताना त्याचं पार्शियल वेपर प्रेशर असणार आहे P2 नॉट. तर पार्शियल वेपर प्रेशर A1 आणि A2 चा असणार आहे P1 P2 आणि प्युअर फॉर्म मध्ये असताना असणार आहे P1 नॉट P2 नॉट. तर राउल्ट्स लॉ आपण बघूया. It states that the partial vapor pressure of any volatile component of a solution is equal to the vapor pressure of pure component multiplied by its mole fraction in solution. In that container, two volatile components are given, A1 and A2. How much amount of pressure exerted by that gaseous phase on the liquid surface at each component exert their partial vapor pressure. So the word used partial vapor pressure of any volatile component of a solution, and that is partial vapor pressure of volatile component A1 is P1 is equal to P1 naught into X1, where P1 naught is vapor pressure of pure component A1 and X1 is the mole fraction of A1. Let's see second, partial vapor pressure of volatile component A2. दुसरा component ही volatile आहे आणि त्याचं partial vapor pressure solution वरती असणार आहे P2 is equal to P2 naught into X2. A2 चं mole fraction X2 आहे, so दोघांचा product, that is P2 naught into X2, that is the partial vapor pressure of A2. Student, you know Dalton's law of partial pressure, that is the total pressure exerted of that specific component is the sum of the partial pressure exerted by that component. ह्या आपण मिक्सचर घेतलेल्या टू व्होलाटाइल कंपोनंटचं A1 आणि A2 हे कंपोनंट आहेत, तर टोटल वेपर प्रेशर जे असणार आहे दॅट इज गिवन बाय Dalton's law of partial pressure, that is P, that is total pressure exerted on liquid surface is equal to P1 plus P2. P1 is partial pressure exerted by A1 and P2 is partial pressure exerted by A2. So P1 is equal to, by using the values from Raoults law, X1 into P1 naught plus X2 into P2 naught. हा Raoults law आहे. X1 and X2 are mole fractions of A1 and A2. As you know, X1 plus X2 is equal to 1. X1 is equal to 1 minus X2. So putting this value in the equation 1, P1 is equal to 1 minus X2 bracket complete into P1 naught plus X2 into P2 naught. On solving the bracket, P1 is equal to P1 naught minus P1 naught into X2 plus P2 naught into X2. So common X2 in bracket, let's see, P is equal to in bracket P1 naught minus P2 naught bracket complete X2 plus P1 naught plus P1 naught. So this is the total vapor pressure exerted by the liquid phase component is equal to P2 naught, P1 naught minus P2 naught into X2 plus P1 naught. Let's see graphical representation how the variation of vapor pressure with mole fraction of solute. When P1 naught, that is when X1 is equal to 1 and X2 is equal to 0, that is totally pure vapor pressure component of pure component A1, त्यावेळी असणार आहे P1 naught हे मॅक्सिमम वेपर प्रेशर असणार आहे आणि ह्या बाजूला X1 is equal to 0, that is X2 is equal to 1, तो मॅक्सिमम सोल्यूट असताना कॉन्सन्ट्रेशन असणार आहे, वेपर प्रेशर असणार आहे P2 naught. Okay, now as the addition of X2 from this region to here, that is mole fraction of X2 is increases from 0 to 1, so there is a decrease in the vapor pressure of the solvent. This is decrease in the vapor pressure of the solute. So this P1 graph, that for P2 second graph for solute. Now this third one graph, that is for total pressure exerted by the gaseous phase from both the component, that is P total is equal to P1 plus P2. So P1 naught, that is that of pure component A1,